So we talked about a career in network automation and the 10 domains of knowledge that you need to master to get there. In this video, I want to continue the conversation with what you need to learn as far as coding or programming is concerned and go over the NetDevOps Toolchain. Be right back. DevOps is about automation, coding, IT operations, and software testing, whereas the NetDevOps role is simply a network-focused DevOps. So it is about coding, network operations, and network-related testing before your network change request is pushed to the production network. If you are with me so far, there are some well-known dilemmas associated with the DevOps role. What am I talking about? Dev in the DevOps. No, you don't have to be a world-class coder to be a DevOps. If you have software development know-how, or preferably you know one programming language well, you're going to be okay. Likewise, you don't have to be a CCIE or a CCNP or even a CCNA to be a network DevOps. What you need to know is the networking fundamentals, i.e. protocols, technologies, and popular vendor platforms and solutions such as Cisco routers and Cisco switches and Cisco DNS Center, what have you. I have covered this topic in detail in another video. There is yet another common question about language preference, i.e. Python versus Go. And the simplest answer to that is to start with Python if you don't know it already. Nearly all of Cisco and third-party multi-vendor libraries such as the NetMiko and Napalm are written in Python. So let's talk about the NetDevOps paradigm. It starts with treating network device configurations as code. So what that means is that we store configurations in source control management or SCM software such as Git. All incremental changes to the configuration are made in the branches. When you push a config change in the Git and merge the branch back into the master branch, it basically triggers the CI/CD pipeline configured on your build server. Now it is also crucial to understand the role of Yang and netconf or restconf protocols. Netconf defines 3 different types of data stores, i.e. startup, running, and candidate. Whereas Yang defines 4 data types, i.e. configuration, state, RPC, and notifications. Yang also defines native OpenConfig and IETF data models. All right. Yang models can be operated on with either netconf, restconf, and RPC protocols. Finally, the Yang data can be encoded in XML, JSON, or protobuf. Let's now talk about the NetDevOps Toolchain. Just like software-based DevOps, the network-based DevOps pipeline is also centered around the CI/CD stage. Right? You can use tools such as Cisco NSO, Viral, like Cisco Viral, Cisco CML, or even GNS3 to build your production replica virtual network that you're going to use for the unit and integration testing. For continuous deployment into production, you can push your configuration changes into physical, virtual, or even cloud-based infrastructure. Now, widely used source code management tools are GitHub, Bitbucket, and GitLab. You can use Cisco PyATS for testing within the CI/CD pipeline. Now, for infrastructure as code or IAC, you can use Ansible, Puppet, Cisco NSO, and NetMiko library. For logging and monitoring, you can use ElkStack, Splunk, Nagios, New Relic, and Cisco's AppDynamic. Now let me run through the mostly used DevOps tools broken out by the DevOps stages that you can use today. I will call out the coding or scripting requirements where they apply. So we will start with the planning stage, right? Planning stage is where the mostly used tools are Jira, Trello, Asana, Backlog.com, and Monday.com. All these tools are hosted in the cloud except for Jira, which can also be self-hosted or what we call on-premise as network engineers. Now, source code management is crucial as the configuration is treated as code, like your network configuration is treated as code and is stored and tracked inside your SCM repository. The most popular SCM tools are GitHub, Bitbucket, and GitLab, which can be self-hosted as well. Now, Amazon, Microsoft, and Google have their own SCM tools that run in their respective clouds. As a NetDevOps, you must be familiar with the Git operations, the Git commands, and best practices. Now, developer productivity tools are important to maintain development environments without inconsistencies in terms of software configurations and versions. And most importantly, the environment should be reproducible in short order. This could be achieved using tools such as Vagrant, Docker, etc., which basically increase developer productivity as well as maintain a reproducible and consistent environments across developers. So again, I have called out which tools are delivered from the cloud and the ones that can be self-hosted. Now, before we move on, let's discuss Vagrant. Vagrant is basically an open source tool that allows you to create, configure, and manage boxes of virtual machines through CLI and Vagrant files. So technically speaking, it is a layer of software that's installed on the host OS and sits between a hypervisor such as the VirtualBox, Hyper-V, and a VM. All right. You can use Vagrant to launch Docker containers as well as effectively, it basically doesn't care what's actually inside the Vagrant box. So Vagrant uses Vagrant files to describe the type of machine required for a project and how to configure and provision these machines. The Vagrant file uses Ruby-like syntax, but you don't need to hand code or modify the Vagrant file. Now, continuous integration and delivery are two of the most crucial phases of the overall NetDevOps pipeline. Continuous integration and delivery are two of the most crucial phases of the overall NetDevOps pipeline. Your build server, such as Jenkins, is what describes how you perform your continuous integration, continuous delivery, and continuous deployment. Now, continuous integration is about merging code, or in our case, configuration changes to continuous integration is about merging code or configuration changes to a central repository within your SCM tool, such as Git, several times a day. Each merge triggers an automated configuration build and testing sequence. So CI serves as the safety net that lets network engineers prevent issues before they affect the end customers. Generally, the time between network changes is pushed like from your SCM tool to the time the CI/CD pipeline completes the execution is no more than 10 minutes or so. So during the execution, your build server uses your configuration management tools such as Ansible, which will in turn execute the playbooks, the Ansible playbooks that will launch your virtual network, push the merge configurations to it, and complete your unit and integration testing. This is where continuous delivery comes in. This is where you have fit and finished configuration files that you have passed, that actually have passed the testing and are ready for being pushed into the production manually. The real final step towards automation here is the continuous deployment. That's the final piece where your configuration file is automatically pushed into the production. Now, obviously that sounds scary, right? So now continuous deployment of network configuration or application software is not everyone's cup of tea. Why? Because a lot can go wrong, and that is precisely why organizations that implement continuous deployment need extra safety nets. So what am I talking about? What are those? Well, continuous deployment requires a highly developed culture of monitoring, being on call, and having the capacity to recover quickly if something goes wrong. In terms of coding, you can expect to write your build script, Ansible playbooks in YAML. If you have a large network with hundreds of devices, you need to be able to also write Jinja to Python templates, which basically contain variables to generate the final configurations for each networking device. We have already covered the continuous delivery and deployment discussion, but here are the tools for continuous delivery and some more testing tools. All right. So now build tools help build application software, or in our case, network configurations. So all you need is a build server like Jenkins that can invoke a configuration management tool, and that can create the virtual network using, say, Cisco Viral or CML, and then deploy those configurations and complete the testing phase. So it is your job as a network DevOps to write your Ansible playbooks, your Jinja 2 templates, and your Docker containers, and your Docker file, and your network, your virtual network emulation or simulation platforms. Now, IAC is about bypassing the CLI or the graphical user interface or GUI to configure a device, and simply use a machine readable definition file instead. So Ansible, Terraform, Salt Stack, etc. are examples of IAC tools. So we covered a lot of stuff. So let me summarize. I would say there are 4 areas here. So number 1, general network automation. Number 2, network operations. Then pure play DevOps and network specific tools. So general network automation knowledge means knowing such as things like Yang modeling language, netconf or RESTconf protocols, REST APIs, and data encoding formats such as JSON. It is also about having some coding knowledge, preferably Python, and also know-how of networking operations, including testing, and the knowledge of pure play DevOps tools such as GitHub, Jira, Vagrant, Docker, Postman, Jenkins, Terraform, Ansible, and some network vendor specific tools as well, such as Cisco Viral or Cisco CML for network simulation, and the third-party Python libraries such as NetMiko or Nornir. If you believe this video added some value, be sure to like it. If it didn't, go ahead and drop a comment. I read all the comments, and thanks for watching, and I'll see you in the next one. Ciao.